So today we're going to be talking about our second factoring method, which is called the AC method. We use this method when we're dealing with trinomials, which just simply means polynomials that have three terms, right? The prefix tri means three, like in triangle, right? Three sides, three angles. So a trinomial is a polynomial that's got three terms. So when we have a polynomial that has three terms and we want to factor it, we will use the AC method. So let's jump on in. So really quick, before we jump into the AC method, let's just do a quick review of what you've learned so far about factoring, okay? So a quick factoring review. When you are asked to factor, remember, factoring means unmultiplying, okay? So you're taking something that's already been multiplied together and you're unmultiplying it. We're putting it back in the form of factors, okay? So your answer should be in the form of factor times factor. Now, whatever is in these parentheses will be different for each problem, right? It might be x plus 2 times x plus 4. It might be negative 3x plus 6 times negative 4x plus 8. Whatever is in those parentheses will depend on the problem. But when you are reading directions, and this is so important, you guys, you always have to be so aware of what you're being asked to do. So when you are reading the directions and you see the word factor, what I always tell my students to do is to circle that word factor and write right next to it factor times factor in the parentheses, just the way I have it here, right next to the directions. So that when you're done with the problem, when you go through and you factor it, when you're done with the problem, you should look at your answer, circle your answer, whatever you get, and then you go back and you look at the directions, and if your answer is not in this form, then you need to make it in this form. So sometimes when you get into doing problems, you forget what you're even trying to do in the first place. When you are asked to factor, you are being asked to give your answer in this form, factor times factor. So write that on your paper, whatever you're doing, next to the problem, so that when you get to what you think is your answer, you go back and you're like, oh, right, I needed to make sure that my answer was in the form of factor times factor, and you look at your answer, and if it's not in the form of factor times factor, then you need to figure out what you need to go back and do, right? Directions are so important. Am I being asked to simplify? Am I being asked to factor? Am I being asked to solve? We're going to be asked to do all these things in this class, and it's important to know what your answer should look like when you're being asked to simplify. What should my answer look like when I'm being asked to factor? And what should my answer look like when I'm being asked to solve? So when you're being asked to factor, your answer should look like this, okay? So, really important stuff. When factoring, always do the following. So when you're, again, think about directions. If the directions say factor blah, 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 factor this polynomial, okay, these are the steps you sort of should go through in your head. The first thing you should do is you should always check for an overall GCF first, okay? You should look at that polynomial, look at every single term, and say to yourself, is there a GCF in this overall term? Do the coefficients have something in common, and do the variables have something in common? And if there is, you pull that out. You factor it out right away, okay? So you always look for an overall GCF first before you go do factor by grouping or the AC method. The first question you should always ask yourself when you're being asked to factor is there a GCF, an overall GCF? And if there is, you factor it out. Now, this is so big. Most people will do that first step. They'll factor out their overall GCF, and then they'll go through and they'll either use factor by grouping or AC method or difference of squares, which we'll talk about in our next lecture, and to factor the rest of the polynomial, and they'll get their answer and they'll forget about that GCF that they factored out at the beginning. That GCF needs to be part of your final factorization. It's one of your factors, right? It's the greatest common factor. It's a piece of your factorization. So when you do factor out that overall GCF, you should like circle it, star it, put arrows next to it, like pointing down, so you do not forget to make it a part of your final answer. Okay, that's super important. So after you've looked for an overall GCF, that's always the first thing you should be doing. Is there a GCF? Is there a GCF? Is there a GCF? Okay, I found it, I've pulled it out, or maybe there's not an overall GCF. Then you move to the second step. The second step is to count the number of terms in your polynomial, because that's going to determine your factoring strategy, right? When there were 4 terms, we knew that we did factor by grouping, okay? If there's only 3 terms, if we're dealing with a trinomial, you will use the AC method to factor it, okay? And actually, if there's 2 terms, we'll talk about in our next lecture what method we would use for that. So first, you're looking for an overall GCF. Second, you're counting the number of terms, and based on how many terms are in that polynomial is the method you will use. So today we're going to be looking at trinomials, so we're going to, of course, be using the AC method because we're going to be looking at polynomials that have 3 terms. So where did the AC method come from? This is just like sort of a little bit of a review. The AC method is basically unfoiling, and hopefully that word foil should set off like something in your brain that you remember. Oh yeah, foiling. I sort of remember that now. Okay, so we're sort of working backwards from foiling. Okay, so when you foiled, you were actually given the factored form. So here we have, look, a factor times a factor, right, being multiplied together. And when you're asked to FOIL, you're actually multiplying those 2 factors together. You would do the firsts, the outers, the inners, and the lasts. That's where that FOIL comes from, right? So when you multiply all that out, when you multiply out your firsts, right, that's 2x times 5x, that gave you 10x squared. When you multiplied the outers, that was 2x times negative 8, which gave us negative 16x. When you multiplied the inners, that was 3 times 5x, which gave us 15x. And of course, when you multiplied the lasts, here they are, 3 times negative 8, and that gave us negative 24. Okay, and then you take all of these lovely answers that you just got. Let me circle that a little bit more nicely. There we go. And you put it together to sort of give you this new polynomial, right? So your 10x squared minus 16x plus 15x minus 24 minus 24. We can combine like terms. This is just like what we did in our review lectures, right? Adding polynomials. So negative 16x plus 15x, well, that just gives us a negative 1x. So when you simplified this whole thing down, you wound up with 10x squared minus x minus 24. So you started with the factors, okay, and then you ended with a polynomial. That was foiling. When we use the AC method, we're basically reversing that process. Now we're starting with this trinomial, and we need to get to the factored form. Okay, so we're undoing the FOIL. That's what we're doing when we're using the AC method. So this is where the AC method comes from, okay? So how do we use the AC method? What are the steps? Okay, it's important for you guys to understand that when we're dealing with a trinomial, a 3-term polynomial, okay, we, as mathematicians, write it like this. This is the general form of a trinomial. We write it as ax squared plus bx plus c, okay? And a, b, and c are our coefficients, our numbers. We know what coefficients are, right? We've gone over and over that at this point. So this is just the general form of a trinomial, okay? We have an x squared term, an x to the first term, and of course an x to the 0 term. And then we have our coefficients that are in front of those variables, a, b, and c. Okay, so those are just the numbers that are in front of our variables. We should feel pretty comfortable with that by now. Right, so that's the general form of a trinomial. So when we use the AC method, these are the steps we're going to take. The first step we're going to take is we're going to label our coefficients a, b, and c. Okay. The second thing we're going to do is we're going to multiply a times c. Okay. Whatever those numbers are, we'll multiply them together. The third thing we're going to do is we're going to find 2 factors of a times, we're going to find 2 factors, whatever we got for this answer of a times c, okay, whatever that answer was, we're going to find two factors of that answer that add to b, so our coefficient b. And that's the undoing of the foiling, okay? And the more you do this, the more you'll see how it's undoing foiling. And then, once we've found those factors, we're going to replace the b term with those factors. So now we'll wind up having a 4-term polynomial. And don't worry, right now just listen. If this is sounding like a lot in your head, we're going to go through examples in this video, so you will get to see how this actually plays out, and it will make a lot more sense when we're doing it. Right now, I'm just talking about it generally, so just listen for now. So now we'll have a 4-term polynomial, and we know that when we have 4 terms in a polynomial, what factoring method do we use? We use factor by grouping, okay? So we're basically going to take this trinomial and turn it into a 4-term polynomial so that we can use factor by grouping, because we know how to use factor by grouping. We know how to do that now. And we're going to use factor by grouping to finish factoring. But it's especially important to note that, remember, if there was an overall GCF, once we finish doing our factor by grouping, we cannot forget to include this in our final factorization, okay? So let's look at an example so that all of these words will start actually making some sense.